questions for let's see, recordings. Record. You? Okay. So the tutorial question is similar to what you're going to get for your test. So these are the topics that we're going to cover today. Okay. So we'll talk about Bernoulli's trial, binomial theorem, binomial distribution, normal distribution, and this thing called central limits theorem. Okay. Central limits theorem is, I understand, is not exactly what we have now, but I rather introduce it to you at this moment so that when you move on, you will be more familiar with it. Okay, so let's get started. Now, what is a Bernoulli's trial? What are the characteristics of a Bernoulli's trial? Anyone?
Independent.
Okay, so each trial or each test is independent, meaning that, for example, you have, let's say, MCQ. By right, question 1 and question 2, what you have for question 1 should not affect question 2. Okay, so that's independent. Any more? There are three major characteristics. So what's the other one?
Only two possible outcomes.
Okay, only two possible outcomes. The third one is actually stemming from these two possible outcomes. Is the probability of these two possible outcomes, must it be the same? Does the probability of right and wrong must be the same? Or can be different?
Can be different.
Okay, so the probabilities of each outcome can be different. Okay, but the probability, right? The probability of correct plus the probability of wrong must be equals to 1. Okay, correct, wrong must equals to 1. Okay. So that's a Bernoulli's trial, essentially. So indirectly, we are saying that, things like your MCQ question, each MCQ is a Bernoulli's trial. Okay, hopefully. All right. Then based on that, what is binomial theorem? What is the purpose of binomial theorem? Binomial theorem. Essentially, binomial theorem is to find out, given n number of Bernoulli's trials, what is the probability of R number of successes? Okay, so example will be, for example, you have 30 MCQ questions, MCQs. So essentially, 30 Bernoulli's trial. Okay, and you want to find out 15 marks. Okay, so you have 15 successes. And very important for binomial theorem is that the probability of each trial cannot change. Otherwise, you cannot use the equation. Okay, the probability of each trial cannot change. Okay, this is very important. In fact, I better highlight this. Okay, it relates to question 1 part 2, 1 part B, 1 part B. Okay. So with that, we have covered Bernoulli's trial in itself. So let's look at binomial distribution or binomial theorem on its own. Okay. Okay. So let's say binomial distribution or binomial theorem theorem. Okay. Let's just state a few things. Okay, so N is the total number of trials. R is the number of successes. P is the probability of success. Q is then the probability of failure, which is actually 1 minus P. Okay. So can somebody give me the equation? What is the binomial theorem equation?
NCR
NCR.
times PR,
Yes, to the P to the
then
power of R.
then times
Right.
Q N minus R.
M minus R. Okay, so this is your binomial equation, or this binomial theorem. Okay, so this is also given in your handout as well. See, handout, where are you? Okay, it is given here, your formula sheet. Okay, this probability distribution is given in your formula sheet. Okay, so we actually give you a fair bit of stuff. For example, your conditional probability is also given to you. Okay, so this is the most few important things. Now, if you read the equation and then you put the wrong thing in the wrong equation, nobody can help you already. Okay. So in this case, we can say that how will you calculate, for example, let's say we done this in your lectures lab already. For example, you have 50 MCQs. Okay, and we want to find out the probability of getting 30 marks or 30 corrects. Okay, it's 4 choices. So how you plug into the equation is essentially R is 30. Okay, so this is the 30 part. Okay, then you have equals to N, which is, let me just erase it. So this is 50, C 30. Your probability of success is 0.25. Okay, R is again 30, 0.75, and 20. Okay, so this is the, this is the same number. Okay, so this is where the number is coming from. Okay, so this is how you work out. Now, it also depends on up to you. For example, if I ask you, what is the probability of getting less than 10 marks or 10 corrects? The question is less than 10. So is 10 included?
No.
All right. Okay, so the probability of less than 10, then you have to calculate one at a time. You have to make sure you calculate probability of 0 plus probability of 1, and so on, all the way to probability of 9. Okay. Another question can ask you, what is the probability of getting, let's say, at least 40 marks? So is 40 included?
Yes.
Yes.
Right. Okay. So the probability of getting at least 40 marks is up to you. you can calculate 40 and so on, all the way to 50. Oops. If you want to do the opposite, you also can. 1 minus the probability of 0 all the way to the probability of 39. It's up to you. Okay, see which one is easier. Okay, see which one is easier. The in the tutorial we have let's see, we have some of these questions as well. So up to you. See which one is easier for you. Tutorial 4 is the opposite. So yeah. Okay, so binomial theorem is actually quite easy. As long as you don't mess up a calculation, punch your calculator correctly, it should be quite easy to do. Okay. So again, let me just write down these two. See which version is easier for you. When I mean easier for you means less equation, means less calculation. Okay. All right, so we come to the next one, which is your normal distribution. Now, your normal distribution is very important. Okay? Normal distribution is critical. It's very important for you. Because if you do not understand normal distribution in this chapter, you are going to get confused from now on all the way to the end of the semester. So that's not going to help you. Okay, if you want to learn statistics, normal distribution is the first thing to learn. Okay. Now, normal distribution has a few important contexts. Let's say, for example, we say that the average is 100. Okay, the standard deviation is 15. Normal distribution is actually a bell curve. My bell curve looks horrible. Okay. Normal distribution is a bell curve. Okay. So this is the x-axis or the data point. The mean is 100. Okay. Standard deviation, you have 1 standard deviation, 2 standard deviation, 3 standard deviation. -1, -2, -3. Is there a limit to the number of standard deviations?
Yes.
No.
No.
Why?
No,
Why?
No limit to the number of standard deviation, which means that it actually, the two lines goes to infinity. The x-axis goes to infinity. Theoretically, at least. Okay. So here you have 115, 130, 145, and this is 85, 70, 55. Okay. Second important part is normal distribution is symmetrical. The left and right is symmetrical about the mean. The left and right is actually mirror image of each other. Okay. And we have done this before. If this is the frequency, so assuming that the line actually have an equation, which it does have an equation of frequency, and we say that the area represents the area under curve represents the probability of something happening. In order to find the probability, we integrate from x to from x1 to x2, we integrate the function. Okay, so you just need to know that area under the curve you can integrate. Okay. The third property is that the line itself does not touch the horizontal axis, which means that these two lines will go infinitely long. The two lines does not touch the x-axis, the horizontal axis. Mathematically, this is called asymptotic. Asymptotic. Now, rather than have multiple tables of means and standard deviation, we actually generalize everything into this thing known as a standard normal distribution. And a standardized normal distribution, the horizontal axis is called the z-axis. Okay. So the first step is, how do we convert between the x-axis and z-axis? Now, the z-axis has a few important properties. One is the mean is 0. The standard deviation is 1. So actually, it means one standard deviation. So indirectly here, it says that this is 0, this is 1, this is 2, this is 3. Here is -1, -2, -3, all the way to minus infinity and plus infinity. So how do we convert between x and z-axis? Or the z-axis sometimes is also known as the z-score. Okay, the equation to convert is z equals to whatever x value that you want to convert minus of the mean divided by the standard deviation. Okay? So you are looking at how many standard deviations away from the mean. So basically, this z-score, you are actually saying that the value x is how many standard deviations away from the mean. Okay. And this equation is also given to you here. See, it is 0, variance is 1. So it's also given to you here already. Okay, so it's up to you to use it. Any problem?
What's the first one again? The no limit to number of what?
What? Which are you talking about?
The first one under normal distribution. No limit to.
No limit to the standard deviations, the number of standard deviations. Because it doesn't touch the x-axis. That's why this line actually goes infinitely long.
Wait, but then if you like convert between x and z, right? I thought like the denominator is variance.
No, standard deviation. Variance is s squared. This is standard deviation. Variance is s squared. Okay. This is standard deviation.
Oh my god, I do wrong. Okay.
This
Sorry,
is variance. Okay. All right. Okay. Now, so let's say if we give you a simple idea, in fact, I can give you an example. Let me just use a different color. Okay, what is a nice terrible color to use? Okay, this one. Okay, so let's say the IQ score, okay, has the mean of 100, standard deviation of 15. What is the probability of finding a person with an IQ score of more than or equals to let's say 133. How do you do that? First, you have to convert the X value. The X value is the IQ score into the Z value. So to convert into Z value, you use this equation here. This equation, which is X is 133 minus of 100 divided by 15. So can somebody help me calculate? What is the value? 33 divided by 15.
2.2.
2.2. 2.20, right? Is it?
Yeah. Yeah.
Okay. So 2.20. How do we find the probability then? This is where we go to the table. So you go to the table, your normal distribution table. So this, what it does is, because it's symmetrical, it only starts from 0. So it only covers this point onwards. So if you want to find the opposite, you flip over. So 2.2. How do you read the z-axis? This is 2. You go 0 point something, so you go 2.2. So 2.2, this is 2.21, 2.22, 2.23, and so on. So 2.2, it will give you here. 2.2, 2.20. Is it 2.2 or 2.22? 2.20, right? Okay. So here gives you 0.10139. Is it? Yeah, 0.0139. Okay. So which means that the probability of a person with IQ above or equals to 133 is 1.39%. That's what I'm trying to say. Okay, any one of you done IQ test before? Or anyone knows your own IQ test, or knows your own IQ score? What do you think is the IQ score? Hello? Nobody? What do you think is the IQ score? Seriously. Just make a guess. Do you think your IQ score is higher or lower than 100? Hopefully.
Lower.
Your IQ score is lower than 100. Your IQ score can't be that low. Okay. In Singapore context, if your IQ, if you by the fact that you finish your primary and secondary school, not the mainstream school, right? Your IQ score have to be above 80, I think. So if it's 80, you cannot 80 and below or below 80, you kind of unable to finish. So you go to special school. Okay. Okay, that's what it means. So we can actually do something like this. Now we can also use the same method and find out the opposite. So let's do a few examples now. So same thing. We use our IQ score. Okay. So average IQ is 100. Standard deviation for IQ is 15. It's actually 14 point something, but doesn't matter. Let's call it 15. So what is the probability of finding a person with a IQ score of less than or equals to 90? Okay. So if you draw it out, it will look something like this. So this is 100. Now I do encourage you to draw out the diagram if you do not know. So 15 here is 85. So 90 is somewhere here. So what you are trying to find is this area. Okay. The blue area. But if you go to your table, you can only find the opposite. So which means that you have to flip over. Because it's symmetrical, what it also means is this is 90. Okay. So you have to first convert the IQ score into a Z value less than or equals to 90 minus 100 divided by 15. So can somebody give me the number? Minus 10 divided by 15 is?
Negative 0.67.
Okay, negative 0.67. Okay, that's fine. Okay, so we want to see if you want to draw this line on the z-axis, this will be 0. So this will be minus 1. Exactly here will be minus 0.67. But you cannot do that. You can only get the opposite, which is 0.67. Okay, and what happened is the red and the magenta and the blue are the same area because it is symmetrical about the mean. It's flipped over. So which means that you are actually equivalent to taking z that is more than or equals to 0.67. Okay. So then you look at here 0.660, 60, 61, 62, 63, 64, 65, 66, 67. So here 25.14, 0.2514. Okay, 14% is less of the population is less than 90. Okay, now you can also do the opposite. What happens if it is in between? So for example, I ask you to find out what is the probability of getting an IQ score between 95 and let's say 110. Okay, so do it step by step. 95, 110, what happened? You have to draw it out. Okay, so here is 100. You have 95, 110. So what you want is the blue zone. Okay. So basically, you have to minus off. It is equivalent to 1, the total area, minus off the probability that x is more than 110. Okay. This, let's call it the magenta zone. Which is here. Okay. Minus of x that is less than 95. Okay, and we call this the green zone. Okay, so you have to take the total minus of these two. Okay, similarly, let's do one at a time. Okay, if we do this first, p that is x more than 110 is equals to z more than 110 minus 100 divide by 15. So here we get z that is more than or equals to 0.67. since we calculated here already. So this part is 0.52514. Okay, then we do the other one, which is here. P x that is less than or equals to 95 equals to 95 minus 100 divided by 15. So it's what? Less than minus 0.2. Okay, so let's look at 0.2 in the table and see what we get. So this is equivalent to more than 0.2. So 0.2, 0.20 here, 4207 equals 0.4207. So this is 0.4207.
So teacher, 0.2 man.
Okay, now go B. Last
5
one.
divided by 15. No, 5 divided by 15 is what?
0.3333.
Yeah.
0.33. So let's look at 0.33. Then let's look at 0.33. 0.30, 31, 32, 33, 37.02. Okay. So this is 37.02. 37.02. Then I have to erase this part here. This is 37.
No, 3707.
So then what is the blue area?
Hello.
So the blue area is 1 minus 0.2514 minus 0.3702, which is, backwards. So what's the answer?
So you see wrong, is it? Hello,
Huh?
hello. You see wrong, is it?
Which one?
It's
The
3707.
Yeah.
It's not 3702.
3707. 3707. 3707. Okay. One, 3707. There. 3707. Okay, so 3707. Okay, then help me calculate the whole thing.
0.3779.
0.3709. So here is 0.3709.
No, 3779.
3779. Okay. 779. Yep, that's how you calculate. Okay. So you have to do step by step. You do not know, please draw it out. Okay, that's all you need.
Then what if like it's like I don't have equals to?
Huh?
What if it's not equals to?
Okay. Actually, for normal distribution, itself, right? When you say that P is X that is more than, let's say, 120, and it's actually the same as more than or equals to 120. Understand why?
It's the line, right? You say the line, there's no area.
Correct. Remember, we mentioned it in the lab before. For normal distribution equals to a specific number is actually 0. It's actually 0. For a very simple reason, if you integrate 120 to 120, equals to 0. because of this. Okay, so it doesn't matter. Kind of doesn't matter here. All right. Okay, save.
Wait, so every time like you want to you have to change the x to a z.
Yes.
Oh, okay.
Then sometimes you may have changed the z to an x.
Why?
Look at the question. See what the question is asking for. Later we will come to that.
Okay.
Okay. Okay. So the next thing that we are going to cover is a bit of a syllabus for now, but maybe it's in the next lecture. This thing called central limits theorem. Okay? Because this is actually quite important to look at the type of question we can ask. Okay, central limits theorem simply says that regardless of the underlying distribution of the population. Okay. If the sample size, if the sample is large, or if there's multiple samples, remember the multiple sample problem we should have. For example, if I want to take your blood, do I take 1 tube or 5 tubes or 10 tubes? Multiple samples. Okay. The population mean is approximated by the sample mean and the sample means. If there are multiple sample means, okay, that means 1, 2, and so on, is normally distributed. And the standard deviation of the sample means is S divided by square root of n, which is also your standard error. Okay, so this is quite important. What it really means is this. For example, you have a population. Come back to this diagram again, population. It doesn't matter what is the distribution of this population. It can be normally distributed. It can be skewed. It can be all over the place. It doesn't matter. But if you have multiple samples, okay, so now you have sample 1, sample 2, sample 3, all the way to sample n. Okay, each one will give you a average, a mean. And each one will give you a standard deviation as well. What central limits theorem says that is this. If I take the averages as a data set, these averages will be normally distributed. Okay. And based on this criteria, one, the population mean is approximate by any of the sample mean. It's the same condition here. Okay. And part 2, more importantly, is actually this. This, if you take it, there is going to be a standard deviation of the mean. If you take that as a data set, this will be the standard error, which you can approximate it using any one of these as because everyone have a sample size, so on. And can understand at least or not? We have gone through this in the very first week already. Okay, but let's see how are we going to use it. Okay, let's see how we're going to use it. Okay, so let's go back to our IQ question again. Okay, so IQ average is 100. Standard deviation of IQ is 15. Okay. Question 1. Okay. What is the probability of finding? Okay, and here I have one thing I forgot to give you. And let's say I test this with, doesn't matter. What is the probability of finding a person with IQ above, let's say, 105? So how do you do that? Probability of finding a person with IQ above 105. So IQ above 105. So you convert back to your z-score. Which is 105 minus 100 divided by 15. Okay, so here just now we already have Z is more than 0.33. Okay. And let's look back here, 0.33 is 37.07. Okay. 0.3707. Okay. So which means that the probability of finding a person with IQ, ouch, my wrist hurts, more than 105 is 37.07%. Any problem with this so far? Yes, no? Look at this first. It should be doable, I think. Okay. So this is a similar what you have in a tutorial, but we can ask the question differently. Okay, we can ask the question in a way that let's see. What is the solution? We have a question that looks just now like that. 6% chance. Okay. Where is the current question? Okay. We can ask the question like this. What is the probability of the average IQ of, let's say, 25 persons that is more than 105? So what I'm trying to show you is this. Question 1 is the probability of a single person, the IQ of a single person. Question 2 is the probability of the average IQ of a set of a sample. Okay, it is just a few words difference, but the calculation is different. So how do you calculate it? You have the average IQ now is more than 105. Okay. So remember just now our equation, our let's say this blue equation. To convert Z and X is the data minus of the mean divided by the standard deviation. So that is what we use in question 1. So let me just write it. But in question 2, we are using slightly different. The standard deviation is no longer the standard deviation. It is the standard error. So which means that the equation now becomes this. Okay. So if you want to convert to the Z value, still 105 minus 100, but the denominator has changed. The denominator is originally 15 divided by square root of 25 persons. That becomes this. So 5 over, you have 15 divided by 5, which you will get 5 divided by 3. So then here, what is 5 divided by 3? Hey people, what's 5 divided by 3?
1.67.
1.67. You look back into 1.67, 1.60, 1, 2, 3, 4, 5, 6, 7. You get this. 475. So it's 0.0475. Okay. So which means that the probability of the average IQ for a sample, or can say a group of 25 persons above 105 is 4.75% chance. Look at the two chances. It is totally different. Okay. One, you're finding the probability of the average height. One, you're finding the probability of the height of a single person. So please read your question very, very carefully. Any problems so far? The axis is different. Okay. The axis is different. Why is that the case? If you draw for question 1, the axis here is your IQ, which is 100, 115. Here is 85, and so on. For question 2, the axis is average IQ, The mean is still the same, 100, but the standard deviation is different already. The standard deviation is 3, so it's 103 here and 97 here. Okay, the two axes are different. Make sense?
So the standard deviation for the second one is standard error.
For the second one is standard error, correct?
Okay.
All right. So this is how you use your what you call your central limits theorem. Okay. With that, we can do your tutorial questions finally. Okay, let me go back to here and let me settle this part. Okay. How dustbin? Okay. How do I delete? Delete. Keyboard. What the hell do you want me to write here? No. Can't even delete now. Anyway, don't bother about it for now. So, okay. So tutorial questions. Okay. Question number 1. The answer is true, false, false, true, true. Okay. Why is question 1B false? Anybody? Anybody, why is question 1B false? If we randomly select 5 students to form a class committee, the number of male students selected follows a binomial distribution. So why does it not follow a binomial distribution? Or why is binomial theorem cannot be used here? Anyone?
Because there's supposed to be only 2 outcomes. I don't know.
Not really. The real reason is it is the probability changes at every picking. For example, let's say out of the class of 25, you have 10 males. So before you pick the first male, it's actually 10 out of 25. After you pick the first male, the probability change to 9 out of 24. So remember binomial theorem, the probability cannot change. That's why you cannot do that.
Also, this is the sampling without replacement.
Yes, correct. Yeah, in a way, this is sampling without replacement. Okay. So question number C, part C. Binomial distribution is a discrete distribution, whereas normal distribution is a continuous distribution. Since they are so different, we shall never use a normal distribution to approximate a binomial distribution. That is false. Okay. Remember in our lab, the 50 MCQ question part, it does look like a normal distribution. Okay. So why is it false is when n is large or when n becomes a big number. Okay. Binomial distribution becomes normal distribution. Okay. So if you learn in your calculus, this is the first thing that you do. This thing called limits. Okay. Limits is when n approaches infinity, your binomial distribution approaches your normal distribution. Okay. All right. So these are the 2 reasons.
But I don't understand the question. What does he mean by approximate a binomial distribution.
Approximate, that means can you use one distribution to estimate another distribution? That's called approximate.
Oh, so like what the question is asking if like we can use like normal distribution and like binomial distribution for like the same thing.
Yes.
Oh, okay.
All right.
Wait, teacher.
What?
Then when do you know the exact point where you can use normal distribution for binomial?
When actually it becomes large enough. The problem is binomial distribution is useful because you do not need the standard deviation. You can use normal distribution, but what is the standard deviation? You have no idea. That's a problem.
Oh, okay.
Yeah. Okay. So this is important. So let's go to question 2. Now, in statistics, we always talk about this thing called approximation. So what is approximation? Now, remember when you do any lab experiment, do you think that your pipetting is going to be 100% perfect? Do you think? No, right? Because your pipette, you can have calibration error. In the first few lab, you start pipette water, you know that there are some errors no matter how hard you try. Same thing with instruments, there are some errors. So a lot of things is actually approximation to some extent. It's estimation as long as the overall is not too the standard deviation is not too big, you're quite okay. Okay, so for question 2, in a large population, 73% is short-sighted. So, so 73% short-sighted, we can say that short-sighted equals 73%. Okay. A sample of 7 persons. Find the probability that all of them are short-sighted. Okay, so short-sighted here means the probability of short-sighted is 0.73. So part A, all short-sighted means that you want to find x equals to 7. So then is 7, 7, 0.73 to the power of 7, and 1 minus 0.73 to the power of 0. Okay, so what you end up with is 0.110. Okay, so you should be able to do this well. Question 2B, more than 5. So is 5 included? More than 5 are short-sighted. Is 5 included?
No.
Okay, so more than 5 means that you calculate for only 6 and for 7 equals to. Okay, so if you calculate properly, you should get 0.396, about 0.396. Question C, you have 3 samples of 7 persons. Okay, find the probability that 10 of them is short-sighted. So now your n is, instead of 7, is actually 21. 10 short-sighted out of 21 will be 21, 10. Here will be 0.73 to the power of 10 and 0.27 to the power of 11. So that gives you approximately 0.00843. Okay. Question D. So what is the chance that, so what is the minimum number? So that at least 99% you pick one person is short-sighted. Okay, so this is a bit tricky. Now you need to find out what is n. So you want to find out, to pick one person is short-sighted is more than 99% chance. Okay, so which means that more than 1%, at least one person short-sighted means at least one person is 99% chance, which also means that you do not know. So what you know is to invert it, the probability of finding 0% who are short-sighted is actually, it has to be less than 0.01% of a chance. So it's the inverse. Then from here, you just construct your equation. Let's say n to be the person that you need to find. 0, you get 0.73 to the power of 0 and 0.27 to the power of n is less than or equals to 0.01. Okay. So any number combination of 0 is always 1. Any number or decimal to the power of 0 is always 1. So you end up with just this 0.72 or 0.27 to the power of n is 0.01. So you bring n down, you ln it. Okay. Then you bring it over, you end up with n, you need to be approximately, you need to be approximately 3.52. So minimum, you need 4 persons so that at least one is short-sighted.
Well, teacher, we supposed to like know this man, the long.
Yeah, of course.
Walao.
Huh?
我全部忘记了 then how?
Then how? Suck thumb lah. Go and read your secondary school notes lor.
But if they never take AMF,
Then you do some way of learning lah.
what?
You can do ln, you can do log or whatever thing. Up to you. But you see, that's the problem. Ln and log is the only way you can bring the power down. If not, then you try and error until you get somewhere lah.
Can try everyone.
Can.
Wait, so
So
if you ln 0.0101, what happens to it? It just becomes 0. Wait, how do you do like in between the second last step and the last step?
So here, what happens is you take from here, you go to ln, that is, you flip over 0.01 divide by ln of 0.27. It is similar to what you have. You have x, y equals to z. How do you actually get x? Z divided by y, right? Same thing, oh?
So you just have to like just type in the calculator and then you get the answer. Okay.
Yeah. Your calculator can be different. Your calculator can be 0.01 ln or ln 0.01. I'm not sure. That's why in the first lecture I asked you to go and find your calculator manual. Okay. Okay, so now okay, so the next question is yeah, what?
How come the arrow, the equals to arrow, is like switch the other side when you put in a fraction? I don't know.
Because you have to move over.
Oh, okay.
Yeah, move over. Okay. So let's look at the next one. Okay. So when the sample size is large enough, the number of people short-sighted actually follows a normal distribution. So your X is given normally distributed with 73 as the mean and 19.7 as the variance. Remember, these are variance, huh? So if you do it correctly, your part E, X is more than 80. Okay. So here you have P, which is Z is more than 80 minus 73 divided by square root of 19.7. Okay, then this gives you P, Z is more than 1.58. That gives you approximately 0.0571. All right, then F, P is between 70 and 80. Okay, between 70 and 80, you draw the graph again. So now you have 73. Okay, so this is 80. So you have 70 here. So you already know that this part, what?
Can I leave it in I can leave it in either like decimal or percentage, right?
Always leave in decimal place or percentage. Never leave in fractions.
Yeah.
Okay, so you know this is 0.50571 already. So now you have to find what is this area. Okay, so you calculate, you get equals to 1 minus the P, that is X less than 70 minus, which is P X less than more than 80. So end up with approximately about 0.6946. So you both convert into a Z value, but because this you already know, this is actually this value, so you convert this yourself. Okay, remember you got flip over. So far, okay?
Yes, sir.
Okay, good. Okay, question 2 is done. Where are you? Question 2. Okay, let's do question 3. Okay, question 3 state that a small company have 2 rounds of interview. Okay, the first round you have, so part A, the first round you have 10 interviewers, so n equals to 10. The chances of each interviewer passing the candidate is 90%, so 0.9. Okay. So you need more, the candidate will only pass, let me see, where's my question, 2, 3. Okay, so the candidate will only pass if you have, a candidate will fail to qualify for second round if there's more than 1 interviewer. So at most 1 interviewer can fail him. So the probability of going to round 2 of interview is actually all 10 interviewer pass him or 1 interviewer fail him. Okay, then you work it out, you end up with 0.736. Okay, so you expand the two out yourself. This should not be a problem. It's actually what we have done all the time. Okay. So let me just take a different color. Part B. Okay. Part B says that for the second interview, there's only 3 candidates or 3 interviewers. Okay. The probability of passing, each interviewer passing is 80%. But the candidate will only secure the job if all the interviewers pass him at this round. So what happens is, in this case, you need all to pass the interviewer, all to pass. Okay, so you end up in this case 3 times 0.8 to the power of 3 times 0.2 to the power of 0. This gives you, so the probability of passing the second round is 5.12, assuming they pass the first round. The probability then of getting the job is that you have to pass first round and the second round. So which means that the probability of getting through round 2 and not plus, multiply by pass second round. So then it is 0.736 multiplied by 0.512 gives you 0.377.
So is you multiply is cause is like 3 diagram, is it?
Correct. You have to pass first round, then you pass second round. It's not addition.
Okay.
Okay. So part C. Part C asks you, what is the minimum number of interviewers that you must, what is the minimum number of interviewees in order to have at least one candidate, one or more candidate having 99% chance. Okay, so let's say you take K as the number of candidates or the interviewees. Okay, which means that to get at least one, okay, you want to have more than or equals to 98% of a chance. But what you can do is do the reverse. What is the chance of not getting a single candidate? So the probability of not getting a single candidate that clears both rounds, K equals to 0. Okay, is less than 0.02% of a chance. Just as the same with what we did for the short-sightedness problem. Then you have N. Okay, but here the probability is this 0.377 to the power of 0. Okay, and then you minus off 0.623 to the power of n is less than or equals to 0.02. So now you end up with n that is more than or equals to ln of 0.02 divided by ln or log is up to you 0.623. That gives you approximately 8.267. So minimum you need to interview 9 persons. All right, so this is the same way of calculation. Question 2 and question 3 is almost the same. What they do. Can you get back? Yes. Okay. Okay. Question 4. Okay, right? Question 3. So question 4. Okay. Gordon Ramsay Cake Company produce cakes and pack into boxes of 6. So n equals to 6. Okay. Each cake can is either a fruit cake or non-fruit cake. So the probability of a fruit cake is 40%. So A is to find the probability that it contains exactly 2 fruitcake. One box contains exactly 2 fruitcake. Okay. So it's 6 to 0.4 to 0.6 to the power of 4. That gives you 0.311. Okay. All right. Now, question B, at least 5 fruitcakes. So it's 5 and 6. So P, at least 5 fruitcake. So you work out P 5 plus 6. So you work it out will be 0.04096. Okay, then we come to the next problem, which is C. So Sehun bought 10 boxes. So now n equals to 10. Okay. What is the probability that at least one box contains 5 fruitcake? So the probability of one box containing 5 fruitcake is actually this, 0.04096. So then you have box at least 5 fruitcake. So this up to you. Which one do you prefer? You can actually do both ways. One is you take 1 minus the probability of a box or rather, let me just write all box does not have 5 fruitcake, or you can do the reverse. You can take probability of one box plus the probability of 2 boxes and so on. So you do all 10 boxes. So presumably you want to do this. So let's work it out here. So it's 1 minus the probability of the number of boxes is 0. So in this case, will be 1 minus 10, 0 here, 0, 0.04096 to the power of 0, multiplied by 1 minus 0.04096 to the power of 10. Okay, so then what you have is 0.34.
Your screen is flipped.
Okay. Let's see.
Okay already.
Okay, hold on. Okay, so because if I don't flip my screen, my arm is going to break. Okay, so anyway, this is the answer. Okay, question 3, question 4. Question 4, okay. Now, question 5. Question 5 states that Paul weekly spending, okay, is the mean is $30. Standard deviation is $10. So what is the probability that he spends more than $40 in a week? So probability spend more than $40. Okay, so this is, so you have to convert back to the Z value. Here is 40 minus 30 over 10. So which then you go to the table 1.0. So this is the one. Okay, 1.01587. So it's 0.1587. Then B, probability that he spends less than $25. Okay. Similarly, less than 25 over 30 over 10 equals to, so here is minus 0.5. Since you can't find 0.5, convert it to the opposite side. That gives you 0.3085. Okay. 0.5 is here. Okay. Question C. What is the least amount that he has to set aside at the beginning of the week so that he's 99% sure that he has enough to spend for lunch? So we say that K is the amount to set aside. Okay, K is the amount set aside. Then you want to have X that is less than or equals to amount K. So it is 0.99. Then you work it out. Okay, convert it to a Z value again, assuming that you have K minus 30 divided by 10 gives you 0.99. But because you can't find that, you do the reverse, which is equivalent to more than K minus 30 over 10 equals to 0.01. Okay. So we also know that K minus 30 equals to over 10. To find the probability of 0.01, this number needs to be, so you go look for 0.01. Okay. Under here, look for 0.01. You end up with 23 point, this number. Okay, you don't take the this number because you end up with slightly less than 99%. So you, from the probability, you find out what is the axis. So 23.0123, 23.3. So you get to 2.33. Multiply up, you have, you need to set aside $53.30. So just answer. Okay? the minimum amount to set aside is $53.30. Okay, so it's the same method of calculation. Okay. Any problem with this? Question 5. Anyone did already? Hello, respond.
Hello.
Okay, good. Okay, question number 6. Okay, the mean lifetime of the fitness tracker is 18.7 months. Standard deviation is 2.05 months, which means that about 18.7 months, half of the tracker will die. Okay, so that's what it means. So question A asks you what is the probability that a particular tracker has a lifetime of more than 20 months. Okay, so if you draw a graph, you are going to have 18.7 here, so 20 is here. You are going to find this area. Okay, so this one is convert back to the exact value. 20 minus 18.7 divided by 2.05. Okay, that gives you, then you read off the table, that gives you approximately 0.2643. Okay, so you have 26.43% of finding a tracker with lifetime of more than 20 months. So B, between 15.5, 15.1 to 19.9. Okay, so if you draw it out, this is 18.7. So what you want is 15.1 to 19.9. So you want this area here. Okay, which means that you're going to minus off something. You know that already. So it is essentially 1 minus more than 19.9 minus less than 15.1. Okay, so this you end up with 1 minus, so more than 19.9 is 19.9 minus 18.7 over 2.05. Okay, and here is 15. Oops. 15.1 minus 18.7 over 2.05. Okay, so you work it out. This will be 0.2776. So here is 0.2776 minus 0.0392. So here is 0.0392. Okay. So here, this is what you have. This is for this. This is for this. Okay. Below, this is for here. So your end result is 0.6832. So this is 0.6832. Okay. Part C. Now, how many months of warranty should the manufacturer give? Okay, if the manufacturer doesn't want to exchange more than 10%. So which means that, remember, by the time you hit 18.7, half of them will die. So if your warranty is 18.7 months, you're going to exchange 50%. So obviously what you're trying to figure out is this region here. It has to be below 18.7. So what is this region? What is this number? That this is at most 0.1. Okay, and that is one way of calculating warranty. So let's N be warranty months. X is less than or equals to N, less than or equals to 0.1. Okay, so you convert it to the Z value. Say N minus 18.7 divided by 2.05 gives you less than 0.1. So in order to find 0.1, you have to find use 0.1 as probability to find the axis. So Z has to be less than minus 1.28. So if you put this on the axis, right, this is the months. This is the Z-axis, so this is 0. Here is minus 1.28. So to get 0.1. Okay, so you put the equation in, you end up with N minus 18.7 divided by 2.5, 2.05. That is less than or equals to 1.28. Okay, so N is less than or equals to 16.076 months. So at 16.076 months, about 10% will die. So the warranty period should be less than, should be, I would say less than, should be equal or less than 16 months. Okay, so that's the answer. Okay, and this is one way of calculating. Huh? What?
How you know that Z is less than negative 1.2?
Your question is how do I know that's less than 1.28?
Yeah.
Because if it's 1.28, then I will exchange 90%. Then I have to pay 90% of the warranty period. Correct?
Don't follow.
So here, basically 16 months, 10% will die, and 10% of the people will come to you to ask for exchange. 17 months, maybe at 15%, or until it hit 18.7 months, 50% of the goods that you sold, people will come for exchange because they've died already. And that's zero here. If you move all the way to 1.28, then you sold 100 watches, 100 fitness tracker, 90 will die before the warranty period, and then you have to replace for them. So which one do you want?
still don't understand.
Which part don't you understand?
Stupid Z less than 1.28.
Okay, so if your warranty period is 19 months, how many percent of the tracker will die before that? Will die within the warranty period?
About 50%.
50%, no? Correct. So it has to be less than 18.7 months, ma?
Yeah, okay.
Hello?
And then how you reach?
Which what?
How you reach negative 1.28?
1.28.
Bro, it's the table. You need to convert
Table,
back.
go to a table. Go to a table. 0.1, 0.1, you go to 0.1, 0.1, 0.1. Here, no?
So but why you never choose 0.0985?
This is closer, what?
It's
Yeah lah,
closer.
but it's more than 10% what. They say you don't exchange more than 10% what.
It's 0.9. Actually, you can do 0.9. It's nothing wrong with that as well.
But then if it's to the question, then shouldn't the 10031 be like wrong because it's already more already.
But this is negative, what?
We not even sweating.
You need to turn to negative, so isn't 0.1003 better than 0.0985?
So you see, 2.9. If 2.9, right, what happened is this. 2.9 in itself will be a bit more than that already, you know, will be here. .9 is actually more than 1 already. More than 0.1 already. Because what you have here is, this is 1.28. 1.28, the area here is 0.1003. Okay. Yeah, 1.29 will be lesser lah. You can. It's actually 16 months or less. So in fact, you can give up to 16 months. That's what you're trying to say.
So both is fine.
Yeah, in fact, you can give up to 16 months because your warranty period, if you want to make it even safer, right, you can calculate what happens if you, okay, let's do again. Let's say that n minus 18.7 over 2.05, okay, is less than or equals to minus 1.29. So then what is n? Minus 1.29, 2.05 plus 18.7. So what is n? How many calculate?
It's still around 16 months.
What's the exact number?
16.0555.
Well, 16.05. So it's still 16 months or less. You cannot have a warranty period of 16.05 months.
Okay.
Basically just agar-agar there can already, right?
It must be logical.
It's logical, ma.
Yeah lah. So in how warranty period you have to be in units of months. It cannot be unit. It cannot be a decimal of a month.
You cannot, but you can have like 6.5 months, ma, like that, agar-agar around there.
Look left, look right, cross the road.
If you 6.5 also, like, you know, people like, oh, 1半, then okay lah. Cannot, man.
It's nothing wrong as well. No, this is 16.05 leh. It's not 16.5 leh.
No lah, saying lah, but if it's like 16.5, it's like reasonable also, right?
Also possible. Then what? What is the 5 months? What's the 5 months? 0.5 months going to be calculated? Is it calculated by that month have 30 days or 31 days?
Walao, the same lah. Divide also 15, then you just give them one extra day, 16 more. I mean, I'm the seller, what, right? I can choose whatever I want, right?
Yeah lah, you can oh. It at the end of the day, it's just your profit only mah.
Yeah, okay lah, steady lah.
Okay, so that's all for today. Have fun with yourself. Let me just save this, and I will post it up.
I have a question.
Which question?
About the Z part, like you see for C, right, 6C, you
Mhm.
put Z lesser than minus 1.28. Why is it not like equal to?
Because it has to be, the warranty period is up to a certain time. You can put equal, it doesn't matter.
Oh, okay.
Yeah, it doesn't
So if
matter
I put
because
equal to, it's also not wrong lah.
here you go back to equal lor. So 16.06, 16.05 months is the maximum you can give. So it has to be lesser than that, ma. That's what
Oh,
I'm trying to say. Hello?
but then like if I put equal to, also not wrong.
Yeah, not wrong.
Okay.
Okay, so that's all for this. Let me, have I saved it already? Yep. Okay.
Sure, I tell you,
What?
to be honest, you teach, right, everything, the according question, right, the explanation, right, everything can understand. But when you ask me to do myself, right, I don't know shit.
You don't know shit, what do you expect me to do?
Yeah lah, no lah, but like you know, your explanation is good, but then like the question is stupid as heck. Then like if I do myself, right, what waste one sia.
Then suck thumb lor.
Walao.
Yeah, otherwise what to do? You'll be fine, don't worry. Make sure the main thing is try to understand how the question is structured. We tend to write the question in a simpler way than the tutorial questions, hopefully.
No, but every time pattern one and badminton one, you see the word all change. You don't know which one, what the hell.
Yeah lah, that's where your English comes in useful ma. As I said, when you do this probability, a lot is dealing with the language itself. It's not easy because of that.
No, but it's like, wait,
Go for
you
that.
say first.
So this subject is science, math, or English
Everything ma.
Walao, how can this? I quit lah.
You can now it's still possible for you to quit. Yeah, it's true. It is like when I look at the what do you have molecular biology for last year, some of the things that you're right, I have no idea what you're writing.
How you got mark on paper, man?
You don't mark a paper, I'm the one checking your paper.
Oh.
So I'm looking at the question, it's like, how is this even right? So I just throw it back off. Then you get less marks than that. Okay. Any other questions?
And for this topic, like the problem is not with like calculating like the forward, but it's calculating like backwards.
Yes.
Like the part like I confused, then I don't know how to do.
Okay. That's why always, if you get confused, always draw out the bell curve and see which area you're supposed to calculate. Everybody do the same thing, just draw out and see which area you calculate until you're familiar with it. Every year, this is the same problem. So that's the only method I can show you. Draw it out, know which area I calculate, and if the two areas that you're trying to calculate overlap, it means that something is wrong already. All right. Okay, so goodbye, have fun. Okay, stop recording.